All right, so our next topic we're moving on to is exponents. And we talked about exponents to some extent with our perfect squares and square roots. So we need to know the vocabulary. So if I have this 2 here with the little 3 up in the upper hand corner, we want to identify the different parts of this number. In this case, the 2, that big number, is the base, and that small number, the 3, is the exponent. So this is 2 cubed or 2 to the 3rd power. The 2 is the base, the 3 is the exponent. All right, so exponential form, expanded form, and standard form. These are kind of the 3 different forms we're going to be converting between our numbers. So exponential, I'm going to bring your attention to the first part of this word. You see the word exponent. So that means that is where the number is written with an exponent. Exponential form, you're writing the number with an exponent. Now, expanded form, think about what it means to expand something, to make it bigger. If you're making a number bigger, like actually on paper, it's taking up more space. Expanded form is when a number is expanded by multiplying the base. And of course, the exponent is going to tell you how many times the base is going to get multiplied by itself. And standard form is just basically the answer. It's what you get once you multiply the number together in expanded form. So in this chart below here, we have some examples. Exponential form, I have 5 to the 4th power, 6 cubed, 2 to the 5th power. Those are all written with an exponent. Expanded form is where you take that 5 and you write it out 4 times. It gets multiplied by itself 4 times. The 6 is multiplied 3 times. The 2 is multiplied 5 times. And standard form is what you get when you actually do the calculating. When you multiply 5 by itself 4 times, you would get 625. 6 times itself 3 times would give you 216, and 2 times itself 5 times would give you 32. So over to the side, we're just going to practice writing in the different forms. We're not going to actually do the calculating. So 6 to the 4th power in expanded form would mean I would take that base of the 6 and I multiply it by itself 4 times. So I'm writing the 6 4 times. Again, we're not going to calculate right now. We're just writing it in that expanded form. Now, if I take this number that's in expanded form, I have the 3 written a bunch of times. If I write it in exponential form, my 3 would be my base because that's the number that is repeated. It's repeatedly multiplied by itself. And there are 7 of these 3's if I count them up. So that would mean my exponent would be 7. So that would be 3 to the 7th power. All right, so just to review, like we had up top, this should look very similar to something we had in our notes with our perfect squares. We have an x that just represents any number. It's a variable representing any number that is that big number. That big number, again, is called your base. We have that labeled up at the top of our page as well. And that small number, in this case, it happens to be a 2. That is your exponent. So in these 3 values here, we're going to practice circling the base. The base, again, is the big number. So in this first one, my 17 is my base. Then I have my 9 to the 7th power. The 9 is the base. 42 to the 0 power. My base is the 42. Then if I go on to the next set of examples, I'm circling the exponent. Again, that's the smaller number in the upper right-hand corner. So 1 cubed, my exponent is 3. And 104 to the 7th power, my exponent is that 7. And in 19 to the 10th power, my exponent is the 10. The base is the big number, the exponent is the smaller number. Now we're going to practice not only converting from exponential to expanded, but then actually calculating it to get the standard form. So 2 to the 4th power means I am multiplying 2 times itself 4 times. So I'm going to actually work this out over to the side here so I have some space to do this. So we have 2 times 2 times 2 times 2. And then you're just going to go left to right, basically. Following order of operations, this is all the same operation. This is all multiplication. So it's the same step. And if you have the same step in the problem, you just go from left to right. So that first 2 times 2 would give me 4. And I would just kind of carry down that other times 2, right, that I didn't get to use. And then that 4 times 2 would give me 8. And then I carry down that other times 2 that I never got to use. And 8 times 2 would give me 16. So 2 to the 4th power would equal 16. But you have to go through the steps of just continually multiplying times 2. 3 to the 3rd power would mean I'm multiplying 3 times 3 times 3. So the first 3 times 3 would give me 9. I carry down that other times 3, and then that 9 times 3 would give me 27. So 3 cubed is 3 times 3 times 3. I do all that calculating, and I end up with 27. And this last example here, 2 cubed, I'm going to write 2 3 times. And I actually can reference something I've already done in that first example. Instead of multiplying by 2 4 times, I'm just going to do it 3 times. So if I just look at those first 3 2's I multiplied together, 2 times 2 is 4, times 2 is 8. So this is just, it's just not as long as that whole first example. I'm just not doing that last step of multiplying by 2 the 4th time. So 2 cubed would give me 8. And then in the bottom portion here, if you notice, all of these are perfect squares. So we're not going to go through the expanded form because we should have these memorized. So 4 squared, if remember, that should be 16. 9 squared would give me 81. And 12 squared, 144. So we were dealing with exponents a little bit with our perfect squares and square roots. I just wanted to review what it might look like if you have an exponent other than a 2 and how you would handle that.